Hello, welcome everyone. So I'm Prashant Gami, and I'm the CEO and founder of X Enabler. This is a technology innovation company. So today, I'm based in Sydney, so it's quite late here, actually about 7 o'clock. So sorry if the video is a bit blurred because I'm just on a room light here. Just to give you understanding, so with blockchain and Web3, we've been doing some amazing work in this space into tokenization and into modern technologies and how they're actually changing the way we do business. Now, what technology traditionally does is basically it doesn't really change the need of the market or the people. What it does, it provides a better way of doing things. And because of that, there are things that were not possible in the past to achieve, to do in certain way. It makes it possible. And today, particularly what we're going to talk about is why blockchain and Web3. What's this whole hype? Why it's all over the news and all over, people are talking about it. So let's go to the basic. What is blockchain? Now, some of you might have IT degree and you know what blockchain is, but let's go to the basic explanation of why blockchain and what is blockchain. So every financial or non-financial company, when they run the business, they maintain a ledger. Now, ledger keeps the book of what the company have, assets, it might be money or whatever. Then every time they transact or do something, they make the entry in the ledger. Now, largely what happens is these ledgers are owned by the company itself, and they maintain that. It gets time to time audited, and then they have a legal responsibility to actually maintain that. But what happens is they don't maintain it as thoroughly as they need to, and there's a reason for it. Of course, there's a vested interest, but there's also lack of efficiency, and there's not enough resource to actually do it. So how blockchain changes that? So what blockchain gives us is basically, it gives us a distributed ledger. It gives a ledger that is not owned by the company, but it actually gets stored in like a public cloud, which has multiple nodes. And that means once the entry is made, you cannot go and change it. And that's very, very powerful, because all the things we know, and Harshad Mehta, Ghotalas, Bazaar scams, and all of those things, they cannot be possible if the entry cannot be changed later, if they are final, right? And this gives very good opportunity, and for the very good reason, it is opposed by a lot of the governments, the banks, everyone, because it doesn't let them play around with the book like they used to, and how they are comfortable with. And that means what blockchain gives is a distributed ledger that the people don't own. And that means entry that is made, every node has a copy of it. The entries are final, immutable. They cannot be changed later. And that, because you cannot change the entry, what every party agreed to and what is executed can be used in the courts later to present as as an evidence, as a proof that this is what happened and this was the outcome and these were the rules that were followed, and all that remains on that ledger. And those rule keeping and rule enforcement is done by something called smart contract, which is a computer program which enforces all the things that needs to happen. So by doing that, what are the benefits? One of the key benefit is blockchain democratizes access to finance. So what happens right now is that if we want to transact, we need to go and use a currency that either government issued or use bonds or anything that banks issued. Some third-party institutes are there which actually provides that trust. Now, right now, the trust is provided by those institutes. But what blockchain does is that the trust is provided by the system itself and not by the entities. And that means the entities largely become redundant. And I'm not saying they will be replaced completely, but they do become redundant, that P2P markets, peer-to-peer transactions can happen with the trust given by the system rather than the institute. Classic example, if you want to see in a traditional world, why without blockchain, look at all the diamond industry or any industry that works not on the financial system of the government, but off the book. And in India, we are very used to it. There are a lot of industries that are not yet regulated and they do not work on the book. What this provides is an opportunity of a P2P transaction. And it allows those industries to operate on a, rather than trusting the people and often getting defrauded by those people. There's a system that can enable the trust in those markets, and it can also help them bookkeeping. It can also help them gain legitimate and efficient. So it eliminates the human intermediaries. Sorry, excuse me. And it increases transparency. And because system is doing this automatically, all the cost that is involved in traditional finance. So when we send money from A to B, we think that, okay, it's just computer program doing that. But in traditional world, what happens is it goes to your bank, then the bank goes to some central entity, then the central entity has their books, then they go to another local agency, might be in US, might be in Europe, then that local agency will go to a particular bank, and then the entry will be made in that particular bank. So there's a lot of human resources are involved, and because of the human resources, there's a lot of energy, there's a lot of time and complexity involved into that. What blockchain does, it automates all that process. So think in a classic world, if you want to do an international transaction, it typically takes few days for the transaction to go from A to B. In blockchain, it takes almost a minute or less than a minute. One of the network actually recorded, I think, around $99 million worth of transaction within few seconds, and it was final. It was completely done. All the books were completed. All the nodes were up to date. So that's very powerful when it comes to financial. So let's look at what is Bitcoin and why all this hype about Bitcoin. So when you have the P2P transaction, the first use case and what was actually blockchain was used for, although blockchain is not only money, we need to keep that separate. So cryptocurrency or currency itself is one application of blockchain. So because you have a ledger can write anything. And one of the main things that it was created for was to write money. Because what they found, take the 2009 global financial crisis, what happened was a single dollar was actually turned 32 times. It was revolved 32 times, cycled in the system. And that same dollar was actually getting spent over and over again without people realizing it. Now, if it was on blockchain, that wouldn't be possible. And that means the devaluation of money is very hard to do on blockchain because you can see every dollar that comes back. And if you try to use that same dollar, you can say, no, that's the same dollar that is already in use. So you can't really do that. And that gives you powerful mechanism that banks cannot cook their books, ideally. They cannot really afford that. So how does it happen? So if you begin UI, we will have a wallet, digital wallet. We will have an address of that wallet. We'll put the money in that wallet, and then that wallet will go to the machine or the computer, and then it will mine that transaction. So what is mining? So mining is basically creating a new token. So what happens in blockchain is basically because all the nodes are in sync, they need to go and take the turn in writing the block, because once the block is written, it needs to be written on every node. So in currency as well, traditional currency, if you look at like the oldest currency that was ever used was gold. And the reason it was used as a currency, A, scarcity, B, a perceived value that people will use, limited amount, and it can be traded easily. Now, those same quality are available in Bitcoin because Bitcoin is scarcity. There are only limited number of Bitcoin you can actually do. Large effort to actually mine it. You cannot mine it without large machinery and the computation power. So it takes a lot of time to mine it, and it can be traded easily between the people. So once the mining happens, it basically, the nodes verify that, and then the first confirmation happens, and then it can be transferred to another person. Let's look at few other reasons why blockchain is important. So one is the time efficiency. As we mentioned, rather than taking days, it takes minutes or less than a minute to actually complete the transaction. Blockchain allows peer-to-peer transaction. That means anybody who wants to do the trade between them and they don't trust the other person, they can still do it by keeping this common system, which neither of them can actually go and tweak. So whatever they write, it's always final, and they can actually put the information there. And that system will make sure that all the precursor or all the conditions that are important for the transaction to actually occur will happen. Think about, for example, a land sale or a house sale. When you transfer a land from person A to person B, the number of checks that happens: A, do they own the title? B, is the title doesn't have any finance or anything like that? C, what country it is in? D, if both the citizens have any tax liabilities, all of that. Any mortgages to pay, any duties to be paid to the government, all those things currently happen manually. Now, if you put that on blockchain, all of those things will be automated. That means you can just put the documents through, the computer will verify it, it will say, yes, all the things are done, and the transaction is able to complete. And all that remains on the chain. That means anybody can go and verify that the process was followed, and it can be audited easily. It doesn't, now there's one very, very important difference of understanding in blockchain. A lot of people come to me and say, oh, so blockchain removes the auditing. It does not remove the auditing. It makes the auditing simpler, because the information that you are looking at are largely trustworthy, because they have followed a very systematic approach, and all the steps have been taken. Now, whether those steps are legitimate and things are supposed to happen, obviously you still need to audit. It improves the traceability. If you look at earliest theft in blockchain, there was about 10,000 or 12,000 worth Bitcoin Ether was actually stolen by the guy who was actually programming it. And it was done actually to prove that he was trying to raise this issue. The people were not really listening to him, that there is a vulnerability in the program. So he actually took out $12,000 worth of Ethereum back then to prove that it can be done. And that $12,000 Ethereum back then is now close to $16 billion. But what happens is, even though it happened like about 12, 15 years ago, they were able to trace it back to the person who actually did it very, very easily, because all that trace is available. Now, if we try to do that in the current financial system, it's next to impossible. Blockchain provides digital freedom and digital responsibility. So what that means is a kind of with more power comes more responsibility, because it does give you freedom to work outside of the designated system, or not involve any entities. But it also means that we have the digital responsibility of making sure that the system is designed in a way that it does not have errors, it does not have loopholes, it is tried and tested before it is applied to the mass. Otherwise, what will happen is a small loophole can really create very large loss or anything, which happened with FTX. So FTX, if we look at it, it wasn't the problem with Bitcoin or blockchain. It was the problem with how people actually thought centralization is same as decentralized system. But what we found out, it was a completely centralized system that some guy were manipulating. And that is the problem with centralization. In the current financial system as well, we see a lot of scams happening because there's central authority who has so much power and they can abuse it easily. So let's look at the case of NFT. Now, those of you who don't know, NFT is basically non-fungible token. So in Bitcoin or in blockchain, there are two types of token. One is fungible token, which means the token actually represents value. And that means if token A is $10, token B is $10, they're identical. They just have the same value. You can exchange each other. They do not have any uniqueness. Versus non-fungible token. That means they have a unique ID. So think about NFT as a unique ID which sits on blockchain, and at any given time, that ID is assigned to a particular artifact or art or bottle, or let's say I just put an NFT on this water bottle, then I can identify that this bottle is this particular ID and I own it. So if I have ledger that proves that I own this water bottle, if someone steals it, I can still go and say, look, this is the same ID as my bottle, like we do in our vehicle, right? We have this identification number that proves that this particular person owns the vehicle, except rather than keeping it in government registry, we keep it on blockchain. And that means any transaction that happens on that particular item, I can sell it, I can rent it, I can do whatever, that will remain on blockchain, and that will allow me to trace that. Why this is important? So if you look at, and I would not probably point at Bollywood actors because I think they're making a lot of money, but if you look at a lot of the artists worldwide, there's a problem. And the problem is that they're not making enough money. And why? Because if you look at current way of consuming music, we all have Geo accounts, we all have Spotify, and we all just stream music. We pay, I don't know what's the price in India, but about $10 a month, and we access unlimited music. Now, which is great for us, but for artists, that means they're not making much money. And a lot of that money actually goes to the record labels like Universal and Sony Music and or T-Series, rather than the artist himself or herself. So what they can do is, the concept is what was called 1,000 true fans. Now, the concept was simple, that if the artist can directly sell artwork to the audience, to the fan base, and make, like, find 1,000 fans who are happy to spend $100 per year on the artist, then they can basically do that direct P2P, make $100,000 a month, a year, and still live a happy life. All right. That was the concept. The original way NFT came was actually in gaming world. So all of us, we played Counter-Strike, we played Need for Speed, we played so many games. Now, when you achieve a certain level in that game, you get certain, pride in that, look, I crossed this level, or I got this particular artifact in that game. Now, in the gaming world, there was no way of owning that particular artifact or prove to people that you actually did it. And when NFT came, it actually basically came that, okay, look, this information proves that this happened on a particular game, but it sits outside the game, so not within the game. Like, you can obviously go and open the game, and if the game has the history, you can actually show it on the game. It's very hard. But what NFT allowed is to keep that information, or the memento, you can say, outside that gaming world and on the chain. And that means you can go and brag to anybody saying, look, I cleared this particular stage of Counter-Strike, or I got a particular weapon that nobody else has. And that allowed them to own that digital memento or digital good that was not previously possible. And that's how NFT actually started. And now it is going in a lot of real world use cases. Now, before I go further, I want to pause for a question, because I gave so much information, and I know blockchain is very controversial subject. So can I just open the floor for questions for anything, about anything in this one?
Hi, sir.
Yes.
Yeah, I have read in many articles that mining of cryptocurrency causes too much global warming, and it is
Yep.
so. Can you speak about it?
Yeah, sure. And it's a very good point. So we all hear about, Bitcoin takes so much power, it's consuming a lot of machine power without doing anything, and it's so costly, and it's bad for the planet. Now, it is true, I'm not denying, and it is true that it takes a lot of machine power the way Bitcoin particularly is designed. And the particular consensus algorithm that is used there is called proof of work. So what proof of work is basically that it gives you a very complex computational problem. The machine has to solve it, and then it gets a right to actually write the block or mine the coin, etc. Now that is done to create the scarcity. That means you do not, like anybody cannot just generate a coin. The beauty though, once the coin is generated, there's no power required to actually transfer that coin and everything. Secondly, what people do is that computational power, what they do is there's no how do you say, criticality to that. That means you do not have to mine at a particular moment. So what people are doing is, if you look at all the grids are never 100% powerful because there's so much power that the grid generates, electrical grid, that it cannot actually transmit that in time. So a lot of the power actually dissipated in heat, or it's burned off, or it's just like, never utilized. So what people are doing is they're setting up these mining operations quite close to the grid and using that excess power to actually do the grid. Like in Australia, for example, Perth is Western Australia has very much problem of power surplus because you cannot, at some time the power consumption is less, and that means you cannot go up and down in electricity production as quickly as the consumption changes. But what you can do is basically set up something like Bitcoin mining next to that grid and use that excess power when you have to produce, but there's no usage of it to actually generate that. And that's how they are actually utilizing that power. Secondly, what they are doing is that by setting up that, Bitcoin can actually reduce the production when you want at moment's notice. And that means if the grid requires larger power, they're actually switching down the operation or minting, and that means the power can go to where it is needed more. And that allows that flexibility. The other thing they are doing is again, I will go to Western Australia, and there's also a couple of plants in New Zealand as well, where it's 100% recyclable. So they're not using traditional coal or any other source of power. What they are doing is basically either the wind power or the turbine or anything to actually mine this. And that means there is no CO2 emission. It's 100% neutral, and whatever energy is actually used gives you that access to the coin without burning much power. I hope that answers your question.
Yes, sir.
Yeah, but the benefit you see, if you look at the traditional way of transferring dollar from yourself to someone else, we only see as oh, it just takes like one click, but it doesn't just take one click. As I mentioned before, it goes from you to another person, to a bank, to a larger entity, financial entity, to a central entity, then another entity, and to the bank. By the time it actually reaches that, the amount of resource that we consumed are much, much higher than what it takes on blockchain. And if you compare those two, how much traditional money takes to actually transfer from people to people versus blockchain takes, it's actually fraction of that. And the good indicator of that is a cost, because always you look at the transfer, you always come at cost. Now, if you look at all over the world, the typical transaction fee of traditional finance is between 3 to 5%. And if you go international, it's around 10 to 12%. With blockchain, it's 0.02% when you reach like a million or something, or millions of dollars worth of transaction. So that cost is almost like just a piece of string compared to the traditional financial world. Yep. Any other questions? And any question is fine. Don't worry about anything being too dumb or too stupid. There's no stupid questions. So fire away. You can ask anything that you feel like. Yes. Sorry, your voice is cutting out. Can you come closer or speak louder to the mic?
Sir, I want to ask what are some challenges related to blockchain?
Yes, thank you. I think very good question. So think about like turning a train is a classic analogy. If you want to turn a train, you can't turn like you turn your bicycle. It doesn't it doesn't have that agility in itself. Now, what we are talking about is changing the fundamental of financial system. Now, to give you idea, in about 1990s, there was a program by IBM called Mainframe that used to run the core banking. Very powerful, very efficient program. Today, almost every bank runs on mainframe, no exception, because nobody wants to just say, look, today the bank is not going to be available. We will just switch over the system, and next 2 months we'll just take the time to turn the bank to the new system. All the the Pay ID came, the digital wallet came, the pay by phone came, Paytm came. All of those technologies are front-end technologies. What we are talking about is a very core technology that does not change almost in 50 to 100 years. It's very hard, it's very bulky, and the cost of any error is very high. The second problem is, so switching to blockchain, although it looks fancy and cool and efficient, it cannot be done overnight. It's a generational change. So it's going to take like at least 20, 30, 50 years for this technology to actually go and become mainstream. And if that becomes mainstream. Secondly, the technology itself is quite premature. It's a lab work. So what happens with technology in general is that it goes to places where the systems are completely broken. Take places like Nigeria, Venezuela, where banks are completely broken, where people don't trust government. Like we had demonetization just 2 years ago, and it was a nightmare. Imagine going to Nigeria, where it's almost like every day, where your money devaluates every day. So today you had $100, 100 rupees. In tomorrow, that 100 rupees is worth, I don't know, 10 paisa. Imagine living in that economy where nothing works. So technologies like blockchain actually goes to those markets and proves itself and makes the difference before it comes to the markets like India or Australia or US. And it's a long way. And changing the perspective of the people. And as I mentioned before, this largely makes the traditional entities redundant. So why would bank want it? If we put this in the bank, the profit it earns by recycling that money 32 times, it goes away. So it does not want this. It's like, by putting this, they're killing their profit. Why would they do it? So as a business, it's very hard. And to do that, what needs to happen is businesses need to shift how they make money into a new way that blockchain provides that is not there in the traditional world. And that's how technology actually makes its place. It gives you new avenue of making money. And if you look at all the crypto scam and why people are going after crypto, although they know there are scams happening, they're losing money and all that, because it's a new way of making money, making wealth that wasn't possible, and everybody wants to try that out. Everybody wants to put some money and see if this can create a new way of creating wealth that wasn't available in the traditional finance. Other challenges apart from that is, of course, the human challenges, skill, all the infrastructure that is required for this. As I mentioned, this is largely digital technology, so it cannot have any analog twin, at least at this point. And we have about 2.8 billion people that are still not connected to internet, and that means they cannot use this technology. So the lot of work that it needs to happen before this actually goes and becomes a successful technology. Obviously, there is another challenge connecting it to physical world. The ways we are connecting is with a QR code or barcode or something. They are very rudimental. So you need to really get more smart devices, IoT revolutions, and a lot of the secondary technologies evolved before this becomes a very valid use cases. Does it answer your question?
Yes, sir.
Okay, wonderful. Thank you. Any other questions before we move on?
Hi, sir. Sir, I had a question.
Hi. Yes.
You told us NFT. Can you tell the current state of the business?
Sorry, can you speak louder? Your voice is breaking.
Can you tell the current state of the landscape?
Currency one?
Current state of regulation
Current state
and legality.
of regulation. Okay, so okay. Now regulation is always like a catch-up game, right? I hope I heard the question right. You asked about the regulation, current stage of regulation, right?
Yes. Yes.
Yeah. So look, with technology, it always happens. We all go through lab experiments. The technology becomes so big, and then it becomes so risky, and then we have some big disaster before the regulation actually kicks in and tries to regulate it. We are actually in a phase where the disaster have already happened. A lot of them. FTX was probably the biggest one, but we can see all the banks collapse in US and everything was part of it as well. So there are a lot of disasters happening, and now regulators are going, we can't ignore this, so we have to do something. And the first response, as always, is okay, we don't recognize this. If you look at US has said no cryptocurrency whatsoever. It's not a currency, it's not a financial instrument, it is not allowed, it's illegal. Australia is taking similar stance. Right now, you cannot transfer from crypto to any currency in AUD. It's just impossible. All the banks have started stopping. Now, what happens is when they try to do that, then it sort of goes like a spring. And what is happening on the other side, behind the door, because we work with a lot of government entities as well at the moment, they are looking at how we can actually regulate it so that people can actually utilize, because it has become large enough where they cannot ignore it. So the regulations are still on a drawing board, on a whiteboard, and they are still being discussed as not being drafted, but more at a stage where should we draft it or not? Because you look at India, India has I think 35% tax on cryptocurrency. Ridiculous, right? If you have to pay 35% of any currency, that means the currency is not viable. And that means it will never become mainstream. So while it is okay to say we allowed it, but we're gonna put a cap on it, it will eventually need to change and accept the way that it actually works. And it always happens as a parallel thing. So largely the traditional institute or government or bank, they will not actually promote this, they will oppose it as much as they can, but it will become so big that they can no longer oppose it, and then they have to put some regulations around that so the traditional industry can survive as well as the new industry can put in. In my opinion, it will take another 10 years before that happens, that we see some day-to-day and regular use of cryptocurrency everywhere.
Thank you, sir.
Yep. Right, let's move on a little bit. Sorry, go ahead. Was there a question again?
Is there by any chance it's possible that blockchain entirely replaces banking systems?
Sorry, I didn't hear that. Can someone please repeat that question? Ketki, you can come on the podium and probably do that.
Can
Yes.
you hear me now?
Yes.
Yeah. By any chance, is it possible that blockchain technology replaces the banking segment entirely? Banking sector.
Banking sector and?
Yeah. Can blockchain replace banking sector?
It cannot. So what happens with any technology, and I always say that to every lecture I take, the changes that technology or any force makes, it's never 0 to 100. It's not about replacement. It's not about getting rid of what we have completely. It's always about going from 48 to 52. It's about marginal improvement. It's about efficiency. It's about finding new ways of doing that. Digital currency came and we all are using our Paytm and PayID and digital wallets. It did not take away the currency in our wallet. We still use cash largely at many places, and they both live in parallel. That's what happens. I think will happen similarly in blockchain space as well, that we will have cryptocurrency and there will be use cases of that, and it will be used as a currency largely in many sectors, but it will probably live parallel to the other sectors as well. So cash and the analog money and the digital, not digital. So there's a difference between digital money and a digitally native money. So digital money is what your bank balance currently is, what you see on your banking app. It shows that you have, I don't know, 100,000 rupees. That's a digital money, and that's a digital replica of your analog money. So you can actually cash out. While if you look at cryptocurrency, it's a digitally native currency, means it does not have analog counterpart. It just digital, there's no other representation of that. So they will probably live in parallel. And banks will also, as we are seeing, PayPal already issued their currency, JP Morgan have their stable coin, India also has CBDC, China did that. There's so many other countries, they are saying this is our digital currency. So the fragmentation we are already seeing. So there will still be fragmentation, and there might be like, particular currency or rupee might be working in a particular economy, and there might be a global, like let's say Bitcoin becomes a reserve currency and it's used as a reserve currency, but then locally CBDCs are used. And what we will be seeing is interoperability. And that means the analog money will be able to transfer to digital money and vice versa without much effort. And there will be some sort of interoperability between Bitcoin and Ethereum or any other currency coin and so on. So that's what we might see, and we will probably see. I don't think it will completely replace that. Thank you.
Yes, thank you.
Right. Okay, next one. So what are the attributes? So one is trust, as we mentioned. Now, why is trust? So let's say we wrote a program that says, for me to actually give this lecture, I need to go through certain checks. I need to have a Zoom link. I need to prove that I can actually talk about this particular subject. I have invitation from the university. There are students who are actually willing to attend this lecture, and I need to be available at that particular time. And we both need to have internet. Now, if we write a program to check all of that before I can jump on and talk about this, then what will happen is that I need to submit some sort of proof to the program. It will verify it. It will then say, yes, that is done. It will probably create a transaction recording that, okay, the lecture is approved. Then it will probably record another transaction saying lecture is being delivered. It will keep the copy of the recording as a proof. And it will say the lecture was delivered at so and so time. This 40, 50, 80 students attended. This was the things that were discussed. And then any given time, if I go somewhere and say, look, I talked at Flame University, I can show that ledger and say, this is the proof, I did that, right? So it gives you trust, because once that information is verified, everybody agrees on that verification. What's a classic example of that? So think about your Touch ID on your phone. So we use Touch ID or Face ID for many apps that we actually use these days. Now that information is not actually passed to that app. All that those apps do is that they just ask the phone or the operating system saying, can you please verify the person's Touch ID that he's the person who he says? And then the phone does that, and phone says, yes, I verified, and verification successful. That success message is enough for the app or anyone to say, yes, the verification was done. Now with blockchain, it's the same thing. you do not write your private information on blockchain unless you are obviously writing something stupid. You shouldn't be doing that. What it does write, it basically creates a hash or a key of the record, and it stores that key. So tomorrow, if someone change that transaction, if you create a hash, that hash will not verify, and that means they will know that the transaction was tampered with. So that's the main benefit, that you can still have the proof, trust, but without actually compromising the privacy that we so much care. So the ledger is public, and that means the exchanges can go P2P, P2P trading can happen, marketplaces can happen, artist to consumer directly, or seller to buyer, farm produce to directly consumer, all of that. Digital goods can be owned. So the cases that we talked about, NFT and all of that, like, gaming, all the mementos, digital goods, wearables, metaverse things, anything. Automated contracts. So what I just described, like the contracts are created and they're largely automated. Nobody needs to sit on top of that. Of course, there will be some assisted version of that, but they will verify and make sure everything happened before they can actually execute. And that also shows us an example of P2P lending. So we might have a system here, which is a contract system. And then the borrower and lender, they agree on the contract, that what is the contract here. The debt is actually provided, and debt is given by the lender, and the market is created, borrower takes the money, and there is a mutual compensation fund created. So borrower automatically pays to the lender through this system. And that means tomorrow, if the borrower gets default, the penalties are already defined, and he cannot deny that, okay, I didn't take money, or I paid and nobody knew, kind of thing, because everything remains on the system, and the system is it's very hard to tamper with, practically cannot be tampered with. Other attributes. So what we talked about, like the storing the key rather than the actual data. So zero knowledge proof. And that means you can still have traceability without actually compromising your privacy, which is very important if you talk about identity. So today we are giving copy of our license, copy of our Aadhaar card, copy of our passport everywhere, every government agency, to prove that who we are, who we say we are. That shouldn't be the case. Like, we should be able to just verify our identity once. The verification needs to be stored on the system, and all we need to do is later on provide the copy of that verification, not the actual ID, to the government system, so they can store the verification ID and say, I received this verification ID, which means I trust that this is the person I'm dealing with. So that is very, very important in ID. Micro visibility. Now, if you look at currently, I think most of you might have seen the Harshad Mehta story. What happens is, when two financial entity and large financial entity, when they interact with each other, the settlement happens over the period. It doesn't happen overnight. And that means you have visibility that the money went from entity A to entity B, but what you cannot see is the real time and the micro level visibility, that if they transferred 1,000 crore rupees from here to there, where those 1,000 crore actually came from, where the individual money came from, which loan, which a particular savings account, or which account actually give them that money that they are able to transfer to other one. Now, because this is a computer driven and smart contract based driven, you have that micro visibility without doing much. You can just simply put the ID of that particular coin, and it will give you entire history of where that coin came from. And that gives you an ability to transact, to actually monitor transaction at a micro level, which is not possible in the current system. Voting and smart contracts. So we're going to look at the case of voting now, which is very, very interesting in blockchain. And probably most of you might not have seen that particular side of blockchain. And automated record keeping. So it provides privacy, micro visibility, and democracy. So how does it actually provide democracy? So there is an application of blockchain in governance, and it is called DAO, Digitally Autonomous Organization. Now, what they do is that you have a smart contract and a blockchain, and the entries are made are not currency, but the governance. So what does that governance mean? So let's say Reliance is a company. Reliance says we are a DAO now. We will take all the decision based on what our shareholder says and what our CEO says and everyone says. And we will keep the voting transparent to everyone, so everybody can vote on the smart contracts, and we will store that vote, and whatever decision comes out of it will be automatically taken and implemented. Simple thing is, we are in a room and we need to set the room temperature. So what will happen is all of us will get a vote that what the room temperature should be. And let's say I voted 32 degrees, someone voted 23 degrees, 24 degrees. So we all vote, and the controller will be actually connected to the system. So whatever the average comes, it will set temperature automatically to that particular level. And that means the voting happens in democracy and the decisions are final. So they are implemented by the smart contract and they are taken digitally. That means everybody can participate in decision making, which is very, very powerful. Why? Because traditionally to do that, there's a lot of resources, geographic problem. You cannot get all these thousands of people on one room and make the decision. It's hard. There are way more complexity involved in that to make sure what the decisions are taken are truly reflection of the mass. There's nobody tinkering with the program and all that, but this gives a very useful tool for the use cases of charity. For example, when we give money to tax is a classic example. We all pay taxes and then we don't know where the taxes are actually utilized. If they were on blockchain or particular network like this one, then what will happen is we will be able to trace every single dollar we paid in tax and where it actually got spent. Now, imagine if that level of transparency is available. Government has to be accountable a lot more than what they are, which is very, very powerful. So digitally native, as we mentioned, these tokens are digitally created, digitally mined, stays on digital, and it's completely digital life. So they're digitally native tokens. Real world link using IoT. So previously we talked about currency and NFTs and things like that. Now talk about real world use cases. So think about an artificial organ. If someone is fitted with an artificial knee, my mom is actually fitted with both artificial knees, and it's very hard to actually trust the system that whatever is actually fitted was A, genuine part, B, was manufactured properly, C, was transported, preserved, and fitted properly. And there's no way of tracing that information. Now, if we put that object on blockchain and make a smart contract, then what will happen is from the day the manufacturing starts, every detail, every certificate, every procedure, every transportation, the temperature it was transported, everything will be stored on blockchain. So you can actually, tomorrow, if let's say something happens, you can actually go back and check that if it was done completely genuinely and properly. If not, who was at fault? And that gives you that complete traceability. And this is something we don't talk about. Like when we talk about blockchain, we talk about NFTs and crypto and all these metaverse and all that. What we don't talk about is the real world use cases. And think about in countries like China, where there's a major problem, this can really be groundbreaking and this can create a trust that is not currently possible. And that IoT link, that smart link to the particular organ or particular crops or particular artifacts is very, very important, and it can really transform the way we actually navigate the system currently. And it's counterfeit because you cannot tamper with the data. If the ID is there, you cannot tamper with those transactions once they are written. Or if you do not if you do not provide the copy of transportation or correct certification of the doctor or anything, it won't even allow you to go through the procedure. Or at least you can go and challenge it that, look, this part of the transaction is missing, and that means that person is liable for the damage, which is really important. And as I keep mentioning, it is immutable. That means once the information is written, it cannot change. And consensual. Why it is consensual? Because when you write the smart contract, you can write all the variables that every party has to agree, and all the blocks has to agree that the transaction is verified and it can be written. And that means you do not need to get into argument saying no, unless you do it, I won't do it. The program decides that. Once the program is finalized, the program won't even let it happen unless both parties actually fulfill their responsibility. So example of supply chain I just mentioned, so I'm not going to repeat that. And that means you have a lot of business cases here. One is currency or trading applications, automated trading as well. There are a lot of smartness that comes into how you can trade, authenticity and trust provision, exchange or mediatory system. So for example, you can create a system that works as a mediatory system between P2P transactions. Traceability solutions. So you can provide a solution that allows you to trace all the transactions that are based on blockchain. Reward and recognition program. So currently we are largely we have so many cards and so many memberships, and there's no way of us really seeing what happens there. But if and now a lot of the company are putting that on blockchain as well, that means they cannot deny it later. Now this is not really about the coupon that you get, but more about, think about if every student, for example, in a university gets a token for being a student and gets a voting power in how the university behaves in future. So right now it is not possible because we have thousands and hundreds of thousands of students, and it's practically impossible to actually get everyone participated and manage that. But if there's a program and there's a blockchain ledger underneath it, you can actually implement that if you want. And that means everybody can participate and be active and get rewarded for being around, or for promoting university, or for whatever reasons. Participation and collaboration platform, which we kept talking about, universities, digital governance, there's so many applications that you can do. I want to just quickly walk through some of the use cases that we worked on. So this is the actually crypto hotel in Arizona, Phoenix, which is like a stock market kind of thing. So it's basically, it has a trading floor, it has NFT art galleries, all the rooms are IoT rooms. So that means the traceability of who stayed, all of that is taken care. They also have the NFT reward program. That means whatever whoever actually stays there gets a token and then gets rewarded and gets benefit because they stayed there. And it's a lot more smarter system. Crypto Toast, which is a trading platform. So what we do is we basically connect trading view. I don't know if you know, but that's like a data of where the prices are with the Binance wallet. And it actually takes the trigger from the algorithm that we feed in, and it actually automatically trades Ethereum or Bitcoin, whatever you want to trade, using USDT. Racer Club, which is kind of like a plug and play NFT gaming experience. So if someone has an NFT, they don't have a utility of that NFT, and they can plug into this club, and it automatically provides the game and everything to the NFT community and allows them to grow the community using that. Ownable, which is our latest and biggest use case, it tokenizes the property. So rather than if you have investment property, you can actually tokenize that. So let's say you have $1 million property, you can tokenize in $1,000 tokens, and everybody can buy $1,000 of that property and get paid in rent and capital gain. So it allows create something similar to stock market for property, individual properties. And that's it. Thank you. Any questions?
Any questions? Okay, let's come here. Yeah, but it's two. You also be able to see that. Take some down. Have a question.
Not really. Can you repeat the question for me? Thank you.
What are the other applications of blockchain?
Hello.
What are the other applications of the blockchain? That's what he's trying to ask.
Any other applications? So in terms of applications, what I think is this technology is still evolving, and we are seeing a lot more use cases that are coming through. Now, one particular use case that I always get attached to is medical, and I talked about artificial organs and all that. The other important use case that one of my friend is working on in India, actually in Bangalore. He's here, but then he has collaboration with Bangalore-based company and universities. So we all talk about farm produce or anything going from farm to the consumer and make sure they're organic, they're done, all of that. What people don't talk about is the insurance. So coming from a farmer's family, I can tell you, when your crop fails, it's a lot more than what you really see. And it's very, very hard to actually prove to the insurance company that you did everything reasonably well in your power, still the crop failed. And the battle keeps on going for years and years. So what they are implementing is that from the moment you actually start preparing your soil, you put all the things like your soil testing report, your fertilization, your soil preparation, everything on blockchain, all the way until the crop is sowed and watered and maintained and everything. And what it does is, tomorrow, if you need to go and make the insurance claim, then you can prove it easily that you did everything in your power and you took reasonable care, still the crop failed. And that means that process of payment and everything can be reduced significantly. On the insurer side, what happens is it reduces their paperwork and the complexity of collecting that paperwork and making sure everything is done properly and all that, to almost once the claim is made, everything is ready to available and decision can be made almost within days, if not more. And this kind of efficiency. So what we think about blockchain, don't just think about new ways of doing things, groundbreaking changes, all of that. Think about incremental efficiencies that it can introduce into the system that can go a long way. And it's very, very important that radical systems like this take incremental changes. It gets introduced incrementally, makes small changes in different sectors and grows. Thank you.
So can DigiLocker also be one of the examples of blockchain?
Yeah, it is actually. So think about not just DigiLocker. Think about anything that currently is provided by the third party or some institution. If you can take that trust and that legibility peer to peer, what can you do? So diamond industry, which I mentioned previously, is a classic example, which is trying to of course, the industry is quite in India, it's quite rudimentary, but if you go in Belgium and everywhere, they are looking at blockchain to actually, because in diamond industry, what happens is they to get more diamond, they actually put the current diamond on as a security to get more diamond. Now, all they have is a trust of that person that they gave him diamond, and there's no paperwork, nothing. So to allow that P2P transaction, something like this is very, very important.
Thank you.
Yep.
Sir, would you tell us how blockchain technologies hold up against short-term widespread connectivity failures? If there's an internet shutdown, widespread connectivity failures. Like if there's an internet failure for a few hours, a few days, after that, it's possible to reconcile it.
Okay, yes. So look, the technology is evolving, and there is a way you can do the blocks that you have globally, and look at layer 2 blockchain, which is something similar to Polygon. So if you look at Ethereum and Polygon, Ethereum, we call it layer 1 blockchain, means the main blockchain. Polygon is layer 2 blockchain. So what is layer 2 blockchain? So what it does, it takes the transaction, many transaction, creates one transaction out of it and writes all together on the chain. And that means rather than going and writing each transaction by itself, you are taking 100 or 1,000 transactions and writing it at once. And that allows them to A, lower the gas fee, B, make sure the information goes in there, and it's more powerful because now you have create a hierarchical system. By doing that, you can actually address this problem of going offline or the system not being available, which happens in traditional finance as well. When you are offline, you can still do the if pause and things like that, which eventually reconciles with the main ledger. So all that will happen is within that particular block, you might have particular network that is still up. So the transaction will happen there, and then they get returned to the main network later. But that is not as widespread and applied yet. So the technology still need to get there. Currently, most of the network that I know, they cannot sustain that widespread failure.
Thank you, sir.
Yeah.
Hi, sir.
Yes.
So my question is about metaverse.
Yes.
So when you speak about metaverse, people are buying virtual real estate in metaverse. So what is your opinion about this?
Look, at the end of the day, there are use cases that does not make sense. I wouldn't deny that. And buying virtual land is something similar. So what people are actually betting on is that there are ways of doing this. And think about this, like let's take example of your university. Now, when COVID hit, we all went remote, and you had to be delivered lecture remotely and all of that. Well, some of those lectures can be done, but some of the lectures like medical lectures or medical practical exams and all of those things, they cannot be done remotely. Metaverse gives you added benefit or highly, I would say, more interactive than purely digital 2D world like you and me are interacting right now. Let's imagine we were all sitting in a metaverse right now, and I could deliver this where you can see me almost like a real life, virtually, obviously, and you can actually interact with me, and it will be more meaningful because I can see everybody's face, I can see where everybody is sitting, what their expressions are, all of that. So it does not, a lot of people, when they look at metaverse, they say replacing the physical world, but it does not replace the physical world. It provides better digital experience where currently the digital means are only possible. And that means there are few players like Decentraland, Roblox, and all of that. They are biggest in this field. And what people are betting on is that a particular land or a particular opportunity in Decentraland is worth something, because tomorrow someone will build a university on that particular one, or a digital experience like a digital thrilling world or adventure world or something that will be worth a lot of money, because that application will be used by people, and they will generate revenue. So when they are buying digital land, what they are actually buying is Decentraland is saying, we have I don't know, 10,000 or 100,000 blocks only. We can only sustain this much. And that means how many applications can actually run on Decentraland are limited. And that means the block, 100,000 blocks are there. And that means you buy one block, that means you have the power there. Imagine that you do the similar thing in App Store. If App Store says, Apple App Store, that I can only host 100,000 applications, no more. Now, currently, obviously, they have millions of applications. If you only had 100,000 applications available, then people will buy right to particular app ID because they know that they can sell it later. It's no different to buying metaverse or virtual land. So use case is, yes, very far-fetched, but there is a use case and there is a business case there. that if someone actually like uses that block or that address later and creates some utility on top of that, then they can actually rent it out and make money off that. Hope that makes
And
sense.
sir,
Yeah.
can you also tell how blockchain technology can be used in organic farming to check the authenticity of
Yes. Yes.
whether it is
So
organic or
well, organic farming is actually, there are a lot of use cases that are happening right now. So one is in organic farming, there are a couple of things happening, not just blockchain. One is robotics is playing a vital role. So what is happening is that there are a lot of people who have land or a place where they can actually grow farm. They do not have time for farming. So there are a lot of robots that are coming. They call it like how do you say, self-maintained or self-watered gardening. And what that means is you put this greenhouse in your balcony or in your backyard, and it just waters itself and does everything. Now, by doing that, you can actually do the farming in your backyard, and you can actually sell or consume that good. If you are consuming, no problem. When you actually sell it, people are getting more and more aware of buying organic things. But if you are buying organic things, then how do you actually rely that it is organic? So currently the trust is provided by the third party, like, there are certifications and there are marks and there are trademarks that goes certified organic kind of thing, right? But if you kept all that information of the, like, how it was produced and how it was maintained and what fertilizer was used and everything, then you can be more assured that this was actually done organic and what you are consuming is actually organic. So that is a large use case there, and which people are actually doing that, particularly in coffee bean, because as you know, Western world is very crazy about coffee and where the coffee beans are coming from.
Thank you so much, sir, for conducting this session, and thank you from behalf of Team.
Thank you. It was a pleasure being here. Thank you so much.
thank you for all the valuable inputs from yours.
Thank you, everyone.
So thank you for all the valuable inputs. We just had a basic understanding of the metaverse and blockchain, and we understood more about it. And we would
Wonderful.
we'll be grateful if you have many sessions in the future also regarding this.
Oh yeah, definitely. I would love
yeah.
to. Thank you.
Thank you on behalf of Flame University. Thank you.
Thank you.
Prashant, thank you so much. And it is like a long weekend actually, for that's what the coordinator
Yes.
told me. So that's why most of the students are also.
Yeah,
Otherwise,
no, that's
he was
completely fine.
requesting me that we should have it next time for sure.
Oh yeah, definitely. We can do it later again.
Yes, thank you. Thank you so much for your precious time. Yeah, bye-bye.
Thank you. Thank you.
Say bye-bye everyone, please.
Bye. Bye, everyone.
Bye-bye.